we're going to talk about the roles of muscles. And I've already highlighted the 3 primary roles I want you to kind of understand here. And you might have an awareness of them if you studied GCSE PE, for example. But the main point I want to make before we kind of get into the nitty-gritty of this is to say to you that muscles can only pull. And it's for that really central reason. Muscles can only pull. Don't know why I wrote that on an angle. It's that for that central reason that we need these different roles. So for example, if we take the gluteus maximus, let me just change colour. If we take the gluteus maximus on this image here, which is roughly what I'm picturing here, okay? And we've got this muscle here. Of course, the fact that it can only pull means that when it does pull, it pulls from the insertion starts to move towards the origin, in which case the actual insertion of this muscle, which of course is here on the femur, which is just down here, is going to ultimately mean that this leg moves backwards in this direction. And of course, we know that that movement is extension. Okay, so if we want to therefore flex the leg, which is the leg coming in front of the body in this sort of direction, raising the leg in front of you, we need another muscle which is going to be able to perform that role in combination with the gluteus maximus, because the gluteus maximus cannot push in this direction. So that is exactly why the gluteus maximus works in combination or antagonistic pairing with the iliopsoas group on the front of the body to produce antagonistic movement. So let's see what antagonistic, let me just write that in there. So muscles must work in combination. I think I just went off the side of the screen there, so I'll write it in again for you. Combination. Muscles must work in combination. And that combination we call antagonistic movement. Antagonistic movement. It sort of sounds like that it's kind of movement that annoys itself, antagonistic movement. But what we mean here is that there's an agonist which produces the movement, and there's an antagonist which allows for the movement to be produced. So let's see if we can detail that out a little bit. So an agonist is what we'd also refer to as a prime mover, a term I'm sure you are at least partially familiar with. What we're saying with a prime mover or with an agonist is it's causing the movement. It causes the movement to occur. It causes the movement to occur. Now, because we just said a moment ago that all muscles can do is pull, of course it causes the movement to occur by pulling. It does it with a pull. And therefore, what we generally find with an agonist, and there are exceptions when we look at eccentric movement, for example, more of which in another tutorial, that generally speaking, or what we'd say is that the muscle often shortens under tension. Okay, often shortens under tension. So let's see if we can look at an example of that. What I've got over here is I've got one of the heads of the biceps brachii. In fact, let me pronounce that correctly. The bicep brachii. Okay, and this one happens to be the bicep brachii short head. It doesn't, you don't really need to worry about that too much, but it's one of two, and this is the short head part. And what we can see here is, of course, we've got the insertion of the muscle down here. Hope you can recognize that this, let me write insertion there for you. Hope you can recognize that the insertion is taking place on the radius, which of course is the bone of the lower arm, which is on the thumb side of the hand. So this is the radius we have here. And the insertion is hit. Now, of course, all this bicep brachii can do is pull in this direction. So, of course, what's going to happen when that pulling occurs? Well, of course, this lower arm is going to go into this position, right? And of course, we would describe that as flexion. Now, we need to understand that that can only happen if the muscles which are on the back of the arm here, if those muscles are allowing that movement to occur. So, of course, during flexion, this muscle here, which is what we call the tricep brachii medius, okay, let's just write that in. Well, I'll refer to it in its general terms. its general description, tricep brachii there, tricep brachii, and this one's actually the medius. Of course, this muscle during flexion has to relax and lengthen to allow that shortening of the bicep brachii to occur and flexion to occur. But of course, once the arm is up in this position, for example, let's say that the arm has become flexed in this position, well, of course, what this muscle on the back, the tricep brachii, can do is it can contract, it can shorten, and then of course the arm is going to move back down into this sort of plane here, maybe even relatively straight down here. And of course, we'd call that extension. So these muscles, the agonist for flexion at least, the bicep brachii, it's allowed to take place, this flexion, because the tricep brachii lengthens and allows that movement. So let's write this in, that the antagonist allows the movement to occur, That's a nice description, and it would be a good sort of exam answer. It does it by relaxing. Okay, so the muscle relaxes. Okay, so it does it by relaxing, and it often does it by lengthening. Okay, now note that I'm mentioning often there because we will later on talk about eccentric as well as concentric contraction types. Okay, and the other thing we say about the antagonistic phase is it's not under tension. Okay, during flexion, this tricep brachii is lengthening and relaxing at the same time. It's not under tension. Of course, as soon as we go into an extension phase, then it's shortening and contracting and causing that to occur. Now, my last point that I'd like to make, I guess the only other point to say about the tricep brachii here, again, we have the insertion down at the bottom, but notice the insertions on the other bone, on the ulna. It's quite nice just to be aware of that, okay? Now, my last point is to talk to you about the concept of a fixator. A fixator muscle is what we sometimes, I got the wrong blue there, didn't I? Is sometimes what we refer to as a stabilizer muscle. Okay, a stabilizer muscle. And sometimes you even see this term used in the textbooks, that not as a fixator, but as a stabilizer. And it's often above the antagonistic pair. Okay, the antagonistic pair. So let's see if we can look at an example of this. I would encourage you at the end of this video to go and research different fixators for different movements. But let's say, for example, that the elbow is flexing, it is being moved, and it's happening as a result of the bicep brachii contracting in this way. Well, in this circumstance, we really need the scapula, which of course is behind this shoulder, to remain in a stable position. And as a result of that, we have a muscle which lies behind here. We have a muscle behind here, which is referred to as the rhomboid. The rhomboid, I'm talking about the rhomboid major at this point, but let's call them the rhomboids in general. And this muscle is attached here to the very back edge of the scapula itself, the shoulder blade. So of course, when this flexion is occurring at the elbow, there's some tension being applied to this shoulder blade, to the scapula, and it's this rhomboid major, which tightens as a fixator to hold that scapula in place and to stabilize that movement. And we generally find that stabilizers or fixator muscles exist above where the antagonistic movement is occurring. That is all from me. I will wish you a very pleasant day. Take care.